Okay, thank you very much for giving us another aspect of the standardization work and the discussion about reshaping the harmonized standards around the world. And we'll move now back to the industry, to Nokia. And Ulrich Rehfuess, who is heading the Spectrum team at Nokia and is working at 5GPP, will join us to give us his view on the challenges of the 5G ecosystem.
Thank you very much for the introduction. Thanks very much for the invitation to this conference. So I'm afraid I'll repeat a few things that had been said before, but maybe I can still add a few aspects to it. So here a triangle of these 5G application cases similar to the one just shown by Jaime. So we strongly believe that 5G will change the world, as it's much more than this top corner of the triangle about, well, more colorful and even faster smartphones. So there are these use cases, massive machine type communication to the left with very distinct requirements like very long battery life, very low cost to really be able to maybe not only equip every container that ships around the world, but maybe even parcels within the container with connectivity to track them, to monitor, let's say, temperature or mechanical exposure and whatever. So think of very cheap devices that may communicate only rather randomly. So certainly you cannot have everything at the same time. They wouldn't have gigabits per second. They wouldn't have milliseconds latency. But then they can last on very, very long on limited battery power. On the other hand, on the right-hand side, there is this critical machine type communication, very low latency, very high reliability when it comes to safe driving in an automated way, for instance, when it comes to factory floor automation, even like the PMSE industry, so I'm having a wireless microphone here, is looking into can they use 5G technology for their purposes. So a very wide range of applications. And then let's say if we talk about the connected car, it's not just in one of these corners. Yeah? So the security relevant things for driving are maybe in the top, in the bottom right corner in terms of these critical communications. The rear seat entertainment resides in the top of the triangle in terms of high bandwidth. So the idea is to map those different services, those different use cases onto what we call network slices. So provide a quite versatile 5G network, which then looks quite different to different use cases, and provide the exact required quality of service parameters via so-called network slices. This then also certainly maps to some spectrum requirements. And it's quite obvious that, well, gigabits per second are not easy to implement in, let's say, 10 megahertz wide carriers. So for the very high data rates, we need very wide carriers. And those cannot be easily found, certainly sub 1 gigahertz. Those go into the very high ranges, and this is what had been in the scope of World Radio Conference 15. So to first look into what bands can be actually investigated for 5G. So this is the process of the World Radio Conference 19 preparation. And that only starts at 24.25 gigahertz, actually. So much higher, very much higher than the current bands, with very different physical properties. So certainly providing those enormous bandwidth, providing, because of the very small wavelengths, very new opportunities like Luigi has shown in terms of integrating even arrays of antennas into the same chip with the baseband logic. So there are huge opportunities, but on the other hand, let's be frank, there are very big challenges as well. And this is why we also need to look in the 5G context in terms of bands in lower ranges where we have more conventional deployment opportunities, where we can build on the existing assets of mobile operators, which are sites and spectrum. And the big opportunities there, and it has been nicely presented before, are these 3 pioneer bands now identified in Europe. So the 700 megahertz range, which is assigned in a few countries in Europe, which is in the process of being assigned, hopefully, across the Union by 2020, as recently underlined by the decision of the Council and the Parliament. So that certainly does not provide for the gigabits per second, but it can provide for this wide area coverage, which is very important for things like this connected driving, highly automated driving, which is also important for smart grid, for managing these distributed solar panels and whatever energy generation going away from the centralized, maybe nuclear power plants to a much more decentralized energy supply for Europe. So I think you get an idea how wide the application areas are and how important this kind of connectivity, 5G connectivity, will become for many, many industry sectors. Then let's say a preview of eMBB, of much faster communication, can be done in this 3438. There are 400 megahertz of spectrum, so that would lead to carrier bandwidths, if done properly, of 100 megahertz or so for operators. And that's significantly more than the 10 and 20 megahertz carriers that we have in the conventional cellular bands. It still can build on existing site grids in cities where we have dense grids for 1800, 2100, 2600 megahertz grids. Certainly can be complemented by small cells, by indoor coverage and so forth. But then we also need, and in a very timely fashion around 2020 to be able to have commercial services, some close to millimeter wave spectrum. And there we're very grateful that really 24, 25 to 27.5 gigahertz is identified as the third pioneer band, which goes into hundreds of megahertz of carrier bandwidth. And as Luigi stated, there is this opportunity of the topmost gigahertz, so 26.5 to 27.5 gigahertz, that would provide a gigahertz of spectrum to mobile operators in very early on. So many of the trials, 2017, 2018, could actually use that. So how could such a European 5G city look like? And I took my hometown. There will be the European Football Championship 2020. And Munich will be one of the cities, so it will be spread across Europe in 2020 with quite some countries involved. So I think it's quite realistic to assume that coverage could be built on the 700 megahertz layer in quite some area around the city. So to really allow for wide area coverage for the services mentioned, namely the connected car applications like the smart grid and whatsoever. Then coverage in this 3.4 to 3.8 gigahertz range, that's probably much more confined to the city center, but it could also cover certainly the traffic nodes like the airport, like the main station, like the way in between the airport and the city, and then back to the stadium, which is also more on the outskirts, and the stadium itself. So let's say a visitor to such a football match could actually experience eMBB with gigabits per second most of his stay during such a football championship event. And then there would be 26 gigahertz layer coverage, more in very limited hotspots. So again, that could be at the airport, that could be in the stadium, that could be in the press center. That should be certainly in all the research facilities and whatever technology development hubs there are planned. For instance, there is a mobility hub planned in Munich, or started even getting operational. So wherever people start developing and then testing 5G applications, they should have access to these very high bandwidths, only possible in the millimetric wave range. And then, well, Luigi had a more detailed slide even on the evolution. Maybe one thing to stress is 5G comes in this very regular 5G release cycles, 3GPP release cycles. 3GPP works on like 12 to 18 month releases that add features. This will very much continue for 4G, so I think we're still having a few additions to 2G and quite some to 3G. But 4G will not stop. 4G will certainly be further evolved in release 15, 16, 17. And at the same time, 5G comes into these release cycles. Release 15 will focus on this eMBB case, so to lay the physical parameters and everything for what is called new radio. Release 16 then will add lots of things in terms of supporting this critical IoT, massive IoT communication types. But you see that things nicely converge from a technology standardization perspective towards 2020. The technology gets mature, as you see, with first chipset announcements. Well, if you have been to Mobile World Congress, or say, I think from all major vendors, you could see quite some technology demonstrations, how things get prepared. So we really need the spectrum by 2020 being commercially available, meaning being assigned. So we have very good progress on the CPT level, on ECC, in terms of having the processes in place to provide those harmonized standards that we need for the economies of scale. So let's say we're on good track there. But then comes certainly on national level the actual spectrum assignments. And well, there had been a few examples how countries work on the various bands. So this is what we need to get in a harmonized way done across Europe to really have that 2020 opportunity of 5G services. Thank you very much.
Thank you.